Okay, today's lesson is 11-5 called confidence intervals. It is pretty lengthy, but again, just what I've been doing this whole chapter is trying to take away a lot of your time that would be bogged down with calculations and showing you how to use the statistics calculator that's online called ClassCalc. It does a lot of things, but it is, I think, the only one online available to you. Now, this can also be done with a TI Inspire if you have that, or an 84 if you know the buttons. And sometimes I put those buttons down there, but if you want to know how to do it with that calculator as opposed to ClassCalc, just let me know and I will be happy to help you. Okay, so to start off, we have something called a parameter, and it is a measure that describes a characteristic of a population. Okay, you'll see those as we read through the problems. Now, when you have something, what we're talking about today are confidence intervals, and in the middle of that interval is your point estimate. Okay, now, if you think about the fact that you could have an interval around that point, okay, you have a left boundary and you have a right boundary. Okay, the distance between the point estimate and a boundary is your margin of error. Okay, so you can see that the point estimate generally is going to be our mean in all of these cases. Okay, and we're going to have a left boundary, which we get by taking the mean, okay, and subtracting this distance here, which is our margin of error. And there's a formula for it, but again, I'm going to show you how to do it easily. So you take your mean and you subtract that margin of error to get your left boundary, or add the margin of error to get the right boundary. Okay. This picture to me is important because it's the gist of what we're doing. And like I said, I'm going to show you how to put in the calculator so you're going to get these very easily. Okay. So as I said, that interval estimate, or your left and right boundary, is a range of values used to estimate an unknown population parameter. The probability that the interval estimate will include the actual population parameter is known as a confidence interval denoted by the letter C. Okay, so well, let's keep going, and then you'll see as we go along. Okay, but that's kind of key. The probability that the interval estimate will include the parameter. That's what the confidence level is. So the confidence level corresponds to the area under the normal curve. Okay, we have our normal curve. The mean is 0, and if you go 1 standard deviation, whatever that z value is, we've been doing it where we didn't have to actually standardize our values because our calculator does it for you. However, the middle of it is your mean, okay? And the shaded region under the curve is your C. That's your confidence level. Okay, if we want a certain interval of confidence level, 95%, then that means that the area under here is 95%. Let's act like it's 90%. So if this is 90%, remember the whole area is 1. So 1 minus 90, or 100 minus 90%, is 10%. So that means you would have half over here and half over there that's left. So some people remember it with this formula. But again, I'm going to show you. So you're just taking 1 minus whatever your confidence interval is, and then dividing it by 2 to find out what goes on both sides. But you'll see, as I said, as we go through and do examples. So that, as I showed you up there, that maximum error of estimate is the maximum difference between the point estimate and the actual value of the parameter. Okay. Again, this is something that it's just helpful to me to have these key points for a reference for you. You don't need to get bogged down with them if you understand what's being represented. When you give a confidence level, that's the area under the curve, which is that decimal we get when we hit CDF. If we're given it, then we use the inverse CDF. So you're going to see as we go through. And that's true with any statistics calculator. Okay, so here is the formula for the maximum error of estimate. Okay, the z value here, I show you at the end because I don't use the z values as we go through here. But if you want to, these are very common confidence levels. And the Z values that correspond to the confidence level are called critical values, and that's these numbers. And again, you could, I tell you at the very end, so you've got some notes if you want to know how to get this number using your statistics calculator instead of looking at a Z chart. Okay, so let's go do a problem. The first problem that we have is to find the maximum error of estimate. Okay, so we have executives at the music label surveyed 125 people who actively download music and found that listeners have an average of 740 MP3s downloaded to their computers. That would be the old way of downloading music. I don't know if anybody does it anymore. Anyway, assume a standard deviation of 86 MP3s. Use a 94% confidence level to find the maximum error of estimate for the amount of MP3s on the computer of someone who actively downloads music. Okay, so the vital information that we have from our problem, we have that the sample size is 125, our mean is 740, and our standard deviation is 86. Okay, the 94% confidence level, if we take 1 minus 0.94 over 2 equals to 0.03. So those are the little white tails that I was telling you about earlier. Okay, and they go find a Z-score. This is the old way of doing it, or another way of doing it. The long way, let's put it that way. That's the formula. And you plug in the numbers that you go, and you're going to get an answer of 14.46, which is 15 MP3s. Now, how would you do it with ClassCalc? With ClassCalc, you go to Stats, and I'm going to do this for you and show you, but I'm just having it written down so it's handy for you. You go to Tests, and then you're going to hit Z interval, okay? And when you hit Z interval, it brings up the word Z interval with 4 blanks. And right underneath it, you're going to see this is the notation that you give you. So you should know that that's sigma. So that, of course, is my standard deviation. X bar is my mean. N is my sample size. And my C level here, or confidence level, is 0.94. So when you put that in, I'm going to go put that in, and then we're going to come back and show you how to answer. So as I said, I'm going to be up here on number 1. I'm going to hit, well, look, it's already there for us. Stat. This time I'm going to Test, and I'm going to Z interval. And that's the thing that I showed you. So this is where it's showing you what you've got to put in. So as I just wrote, my standard deviation was 86. My mean is 740. My sample size was 125. And my confidence level was 0.94. It's done all the work for you. So this is the interval. Do you see that right there? So I'm going to go back to our problem and put that down. So that shows up right there. So I wrote this in here, okay, because this particular, when it's asking for the maximum error of estimate, then basically, okay, just to show you back on this diagram up here, they're asking me for this. And what I know from my problem, my ClassCalc gave me, this number, 18.1, and that number of 22.7. And I already know the mean. So how am I going to find this? Well, I just have to subtract the mean from one of those numbers. So I picked the bigger one. I subtract the mean, and that's going to give me 14.5, which rounds to 15 MP3s, because I can't really have half. Doesn't do any good to have half of an MP3. You're not going to buy half of a record. All right, what does that mean again? It means with 94% confidence, the population mean for MP3s downloaded will be no more than 15 from the sample mean of 740. Okay? So that is when they ask you, just basically tell me, how far can I go left or right and still be 94% confident that that's one of the numbers? Okay? Now, next, we actually have to find the interval. Well, how would we find the interval? Well, we would just, ClassCalc is going to do it for us, but basically you would just add that number to your mean, add and subtract it to your mean, as we said. So this is what that formula is telling you. You take the maximum error of estimate that we just calculated and add or subtract it to your mean. So that's just it in a little more detail. But I'm going to show you again how we can do that easily with ClassCalc. Okay, and definitely make your homework easier. A sample of 65 randomly selected mall patrons show that they spend an average of $70 a day. Assume a standard deviation of $12. find a 95% confidence interval for the amount spent by a mall patron that day. Okay, so I'll start off with what they're giving it to you. You know, should write it all down so that you know what to put into ClassCalc. And the rest of it kind of goes along with filling into the information and putting it into the formula, and then taking that and adding or subtracting it to your mean. Okay. Again, I want to tell you what to do with ClassCalc. All right. With ClassCalc, if I'm looking for a confidence interval, then I need my Z interval. So I'm going to go back here, and I'm going to clear it just so you can see me hit the buttons again. Stat, test, Z interval. What was my standard deviation? My standard deviation was 12. What was my next thing I have to give me? My average X bar is 70. What is my sample size? 65. And my confidence level is 0.95. So those are my numbers, 67.08 and 72.92, which, if you can see, is right there. Okay, so I'm just going to write down the numbers so that you can see. Okay, you can see from this information right here. Look at this. I just took the information from the problem. I didn't have to do any calculations, but I had to know what I was getting, and I need to understand what it's asking and how to find the answer on my calculator, because there's a lot of stuff on the screen and you might not know exactly what it is. Okay, let's do another one. Suppose a random sample of 50 units of the same material is normally distributed with an average tensile strength of 39.2 KSI and a standard deviation of 3.1 KSI. Estimate the mean tensile strength with 99% confidence. Okay, so, oops, didn't mean to do that. So with ClassCalc, I have I'm looking for a confidence interval. Okay, and I'm going to push Z interval. So hopefully you can tell me this first one is asking for standard deviation. My standard deviation is 3.1. It's asking me for, the next is my mean average, which is 39.2. Then it asks me for my sample size, and then it asks me for my confidence level. So again, I'm taking the information straight from the problem. Okay, if you want to see the math, there you go. You're going to plug it into the formula and get your maximum error estimate, and then you take that and add or subtract it to the mean. Okay, and before we get what that answer is, I'm going to go put it back in here so you can remember. Stat, test, Z interval. Okay, my standard deviation 3.1, my mean 39.2, my sample size 50, my confidence interval 0.99, and it gave me 38.07 and 40.33. Let's see what I put down. 38.0, okay, so I rounded it. 38.1 and 40.3 KSI. And there you have your answer. Okay, so the next thing we got to talk about in here is sometimes you don't know the standard deviation of your population, or your sample size might not be greater than 30, in which case it's not a true estimate. So they have something called a t-distribution, and it is a family of curves that are dependent on a parameter known as degrees of freedom, okay, which are equal to n minus 1 and represent the number of values that are free to vary after a sample statistic is determined. Okay, you don't need to get bogged down here, but what's really most important is if your sample size is less than 30, then you need to be thinking of a t-distribution instead of a normal distribution. This allows that t-distribution to be similar to a normal distribution. Okay, the standard deviation, however, is more than 1. As n increasing, the distribution approaches the standard normal distribution. So that's what is allowing us to use it. Okay, so we use what is called a t-value rather than a z-value. Formulas are the same if you want to do this the long way. And again, your confidence interval is the same, is you're finding that error of estimate and adding or subtracting it to the mean. Okay, but let me just show you quickly. how you do that with ClassCalc. So I have the waiting time of 10. Okay, there's my sample size of less than 30. 10 randomly selected customers at a restaurant was measured with a mean of 25 minutes and a standard deviation of 4 minutes. Find the 99% confidence interval of a mean waiting time for all customers, assuming the variable is normally distributed. So, what is different about this? My sample size is less than 30, so instead of having a normal distribution, I'm using a t-distribution. So that means in ClassCalc, I'm going to go to Stats, I'm going to hit Test, but this time I'm going to hit t-interval, and it brings up a very similar looking thing, but the notation looks a little different. This time we're putting the mean first, and then the standard deviation, still asking for the sample size and the confidence level. So in my problem, what is my mean? My mean is 25. My sample size, my standard deviation is 4. My sample size is 10. And my confidence level is 0.99. So let me go do that for you. So in ClassCalc, I am going stat, test again, and not z interval, but this time I want a t interval. And so it asked for my mean, and my mean was 25. My standard deviation is 4. My sample size is 10. And my confidence level is 0.99. So I have an interval of 20.89. We'll go to 20.9 and 29.1. Okay, so that is right there, 20.9 to 29.1. Again, I put all the information in here if you want to do it the long way, and these are actually the steps that you can use. N stands for Inspire, 84 is on a TI 84. And again, for the Inspire to help you, you can use this in here and enter the information just like I did here, and it will give you your confidence, your interval. Okay? All right. So they go through, and again, they're highlighting on the fact that it has to be, your sample size has to be greater than, if it's greater than 30, use normal distribution. If it's not greater than 30, use the t-distribution, which is what we just did. Okay? So, and it's important. One of the things that they're trying to do in statistics is to make sure they have a high confidence level and a small confidence interval, because that is giving us what they desired. And you get that by increasing the sample size. So sometimes it's important for them to actually, given the information, they want to know, what does my sample need to be to achieve that? Okay, so that is a formula. And I'll tell y'all, when you study statistics, if you do it further in college, they always give you the formulas. So you don't have to memorize them, which is why I'm maybe not as concerned about you plugging them in correctly. I'd rather you save it for some other stuff and enjoy the statistics and understand what's going on. So let's do an example here to find the minimum sample size. Executives at a car dealership want to estimate the average age of their customers before making a television commercial. They want to be 90% confident that the mean age is plus or minus 2 years of the sample mean. So think of that plus or minus 2 years of that interval. You're at your mean and you're going adding 2 or subtracting 2. So that's your error, maximum error estimate. Okay. If the standard deviation from a previous study is 12 years, how large should the sample be? Okay. This one, y'all, you actually can't use ClassCalc to do this. So you don't have all the information because we're looking for that. So we have to use this formula. And that formula says N equals Z. N is your sample size, equals Z times sigma over E. Okay. Now, in our equation, or in our word problem up here, we're looking for N. Z, we don't know, but that is tied to my 90% confidence. And that was the chart that I gave you way up at the beginning. I told you I was going to talk about it at the end, and I am going to talk about it. Sigma is my standard deviation. We know that's going to be 12. And E, as I said, whenever you see the plus or minus, that's your maximum error estimate. So that's going to go in there for E. You don't have to worry about the plus or minus because you're squaring it. Okay. But real quick, you can, again, either go to a Z chart or memorize those numbers up at the top, or you can use ClassCalc to find that Z value. Okay, you go to Stats, Dist Plot, and Normal Distribution, and this time you just put in 0 and 1. That'll give you any number you want on your Z chart. And if I'm looking for a 95, okay, so why is it 95 when they asked for 90? So if you remember back from the beginning, okay, we had the two white parts on the side. So the area under the curve has to be 0.9, which means there's going to be 0.5 on one end and 0.5 on the other. And I want everything to the left of that 0.95. So when I look at that number, that's how I get that Z-score. So when you do, actually, I'll do that for you real quick. Okay, so I'm going to go Stat, Dist Plot, Normal Distribution, okay, and I'm looking for a Z-score. So to get that Z-score, I'm going to put in the mean is 0 and the standard deviation is 1. And I need that probability, so I'm going to go back to Stat, Dist Plot, Inverse, and 0.95. And that's where I get my Z value of 1.645. And that is the number that we're going to use for Z. And I plugged in 12 for standard deviation and 2 for my maximum error estimate. And that gives me an answer of 97.4169. There's a study tip on here for a reason, and that is you need to remember that you always, always, always round up when you're looking for the sample size. So the answer is going to be 98 customers. Okay, so that is confidence intervals. I hope that I gave you a good understanding of it. If you have any questions, please don't hesitate to email me or set up a Google Meet. Thank you, and y'all have a great day.